Let's begin with the story of TBX, a steel manufacturing business that plays a vital role in railway construction. TBX manufactures high-quality steel, which is used to build railways. The method of production used allows TBX to benefit from economies of scale. The business holds a high level of inventory, including iron ore. The managing director knows business activity could have an impact on the environment and is considering ways the business can contribute to sustainable development. Now, we explore the ways in which TBX's business activities could have an impact on the environment. Air pollution caused by TBX's use of machinery and heavy industrial processes that release smoke and harmful gases during steel production. Depletion of natural resources such as iron ore, which TBX uses in large quantities to produce steel. Noise pollution from the operation of heavy machinery at TBX's manufacturing plant, disturbing nearby communities. We then turn to how TBX could contribute to sustainable development. Recycling production waste. TBX could recycle scrap metal and reuse it in the steelmaking process. Investing in cleaner technology, TBX could install filters to reduce air pollution from its factories. Energy efficiency improvements. TBX can switch to using renewable energy sources like solar panels to reduce carbon footprint. TBX also benefits from several economies of scale. Economy of Scale 1, Economy of Scale 1, Purchasing economies. Point: TBX can benefit from purchasing economies of scale. Explanation: the business can buy iron ore and other raw materials in large amounts, lowering the cost per unit. Example: for example, TBX may negotiate better deals with suppliers due to its high volume orders of iron ore. Link: this reduces the cost of steel production and increases profitability. Economy of Scale 2, Technical economies. Point: TBX may also benefit from technical economies of scale. Explanation: by using advanced machinery, TBX can produce more steel at lower costs per unit. Example: for example, TBX might use automated production lines that require fewer workers and produce more efficiently. Link: this improves efficiency and lowers unit costs in the long term. Extra answer: managerial economies. Point: TBX can also benefit from managerial economies of scale. Explanation: the business can hire specialized managers for production, finance, and environmental compliance. Example: for example, employing a dedicated operations manager could improve production planning and reduce waste. Link: this leads to better decision-making and operational efficiency. However, TBX faces several possible problems of holding a high level of inventory. Problem 1: high storage costs. Point: one problem is high storage costs. Explanation: TBX needs large warehouses to store iron ore and finished steel. Warehousing steel is expensive. It also needs security and insurance. Example: for example, TBX might pay more to store steel safely to prevent rust or theft. Link: these costs reduce TBX's profit. More money is spent on storage instead of other activities. Problem 2: risk of obsolescence. Point: another problem is the risk of obsolescence. Explanation: demand for steel might change quickly. Better materials may enter the market. TBX's stock could then lose value. Example: for example, rail companies may prefer newer, lighter steel in the future. Link: TBX could face losses if its current stock cannot be sold. Extra problem 3: tied up capital. Point: another problem is tied up capital. Explanation: money used to buy stock cannot be used elsewhere. This reduces cash for other business needs. Example: TBX may delay buying new machines due to lack of cash. Link: this limits TBX's ability to grow or respond to changes. Extra problem 4: risk of theft or damage. Point: another issue is theft or damage. Explanation: large inventories increase this risk. Accidents or disasters can also cause losses. Example: TBX could lose valuable iron ore in a flood or fire. Link: this would harm TBX financially and delay production. Finally, we explore whether quality control is the best method for TBX to use to achieve quality production. Advantage of quality control. Point: quality control ensures products are safe and reliable. Explanation: TBX checks products at the end of production. Defective steel is removed before delivery. Example: for example, TBX checks its steel for cracks before sending it to railway companies. Link: this keeps TBX's customers satisfied. It protects TBX's reputation. Disadvantage of quality control. Point: quality control can waste resources. Explanation: problems are found too late. Money and materials are already used by then. Example: TBX may need to throw away faulty steel after production. Link: this increases costs. It also leads to higher waste levels. Alternative approach, quality assurance. Point: quality assurance prevents problems early. Explanation: TBX checks each stage of production. Errors are spotted before products are finished. Example: TBX could check raw materials, melting, and shaping processes. Link: this reduces waste and saves costs. It also improves quality throughout production. Evaluation: TBX's main objective is to produce strong, reliable steel for railway projects, so quality must always be maintained. However, a major challenge with quality control is that it detects faults too late, causing waste and extra costs when faulty steel must be discarded. Time is another important factor, as TBX must meet strict delivery deadlines for railway construction. Methods like quality assurance are quicker because problems are identified during production, helping save time. Cost is also crucial. Quality control increases costs due to waste, while quality assurance reduces long-term expenses by preventing defects early. In my opinion, TBX should focus on quality assurance, as these methods are more efficient, save costs, and help meet both customer expectations and production deadlines, making them better suited for TBX's goals.